Okay, so now after we have found out the Thevenin voltage, we're set out to find the Thevenin resistance. The Thevenin resistance can be found by disabling the independent source. In this particular case, the independent source would be shorted, like here. Now the standard procedure is to reduce the resistors into a single resistor, and that way we can find out what the RTH is. However, in this case, it's not so simple, because if we were to reduce all the resistors, then we would be hiding the I1, and we would have a problem with this dependent source. So the way to find the RTH is to interrogate the circuit with either a voltage source or a current source. Now let's use the case of using a voltage source first. All right. So in this particular case, we are going to reduce the circuit and introduce a voltage source. Now the voltage source can be 1 volt, 2 volt, it doesn't matter. For the sake of simplicity, we are going to use a 1 volt. And we know that the current running into this would be called Ix, and the voltage here would naturally be 1 volt. We're going to call the voltage here V1. So how do we find out about what the Ix is? Well, let's see. It turns out that the standard procedure of KCL and KVL is the best way. Now what we're going to do here is to look at this particular node here. All right, and we're going to find the current running in and out and out. So V1 divided by 40 ohm, that's the current running out of this branch, plus V1 divided by 200, that's the current running out of this branch, has to be equal to the current running in here, which is 1 minus V1 divided by 100. Now we got a lucky break here, because this is a equation that consists of only one variable, so we can easily find that V1 is 0.25 volt. Once we find V1, we can find I1, and we can find out what this 1.5 I1 is. Then the rest of the current is pretty straightforward. Now we're going to use this node here, the red node. The red node allows us to write another equation, which says 1 minus V1 divided by 100, that's the current running out of this branch here, has to be equal to Ix plus 1.5 V1, 1.5 I1. I1 happens to be equal to V1 divided by 100, if you recall. So now we can easily find that Ix is 4.5 divided by 800. Well, it's actually not that easy, but let's assume that that's the result here. And the RTH value would simply be 1 volt divided by IX. And this is 177.8 ohm. That's the final answer for RTH. And there we have it. An alternative method would be to introduce a current source and find out the voltage. We're going to show you that at the next